Okay, last time we solved some question related to the speed time and distance time graph, right? And I also shared the PDF file in the group, so you may solve the remaining questions. Okay.
All right, sir.
And in this chapter, one more important concept that is related to terminal velocity, as you already observed in the PDF file, that there are many questions related to the free fall motion, right? A stone is dropped from a height, an object is moving freely in air like this. So the concept which is related to free fall motion is, okay, during free fall motion, actually there is no external force acting on a body, right? Only a force of gravitational force, or we can say that the gravitational strength or gravitational field is going to be act on a body, right? So that's why we consider it is a free fall motion. Normally, if we want to move a body from rest state to a motion state, so we need to apply a force on it. That is known as external force. But since the gravitational pull is a natural one, so that's why we consider it as a free fall motion, right? Because the gravitational pull remains same every time on each body, but the external force depending upon the object on which we are going to apply the force. So basically in free fall motion, if we start from the initial stage, let's suppose this is our starting point, where object is at rest. So object is at rest state. Let's suppose we want to drop this ball from the top of the building, and this is our initial stage. And at this initial stage, the initial velocity of a body is equals to 0, right? And when this ball starts moving towards the ground, so before hitting the ground, there will be some changes in the velocity and acceleration of an object, right? Let's suppose if we start moving from the initial stage. So initial the velocity of body is equals to 0, but after some time, let's suppose if you observe this ball at this point, so what will be the velocity of this ball? Initially we started
Greater
from
than zero.
greater than 0 because we are not counting in numbers right now, but still it is greater than 0. So now velocity will be greater than 0. But there is another problem. Since we are going to perform free fall motion, so when object is moving in downward direction, so there is an other quantity which is going to be act in the opposite direction, which is known as air
Air
resistance.
resistance.
Yes. So due to this air resistance, uh, there will be a change in this point in terms of velocity, in terms of acceleration, and the concept of the terminal velocity will achieve somewhere after that point when air resistance balance the weight of the body. So in free fall motion, actually this motion is due to the gravitational pull of an object. And normally sometimes we also consider that object is moving or object is dropped from a height and we neglect air resistance, right? So if we neglect air resistance, so all object move with same speed, or we can say that same acceleration due to gravity, right? So
Yeah.
free fall motion, if we consider without air, so in this situation we can say that all objects in a uniform gravitational field, in a uniform field falls with same acceleration. That's considered small g as 9.81 meter per second square. right? Same
Yes.
acceleration. But the problem is that we have to consider air some. So the second situation is consider a motion of a body with air. So when we consider air resistance is a free fall motion, the scenario will be different. It is the surface area, the height, all these things are very much important for a body when it is moving free fall with the help in the presence of air resistance. So now it depends upon basically two things: the weight of a body, which is very much important, and the second thing is the air resistance, or we can say that it is a type of frictional force because it is going to be opposite that of motion of a body. Okay, and there are several examples for free fall motion like the skydiver, or let's suppose if we consider example of a paratrooper. So different examples are there in our daily life related to fall motion. This is a very general concept related to free fall motion, and we know that air resistance will always act in the opposite direction of the motion of a body. So that is also a very normal. So friction or frictional force. Frictional force means we are talking about air resistance always act in the opposite direction in an opposite of motion. So this is a basic concept. These are the basic terms and terminologies related to the free fall motion. But the problem is that we need to study about the concept of terminal velocity, right? So the term of terminal velocity is nothing like a new term or nothing like a new concept. It's just like a point where the speed of an object or the velocity of an object becomes constant during free fall motion, right? So we need to learn about terminal velocity because most of the questions are related to this term terminal velocity, because free fall motion is not a difficult task to explain or to understand, but terminal velocity is the important part because most of in questions they ask about to draw a graph for this part or this interval like that, or different explanations was there related to terminal velocity. So basically if we want to write for terminal velocity, so we achieve terminal velocity, or in simple words we can say that terminal velocity is a constant velocity, or we can say that it is a type of constant velocity at specific position during, right? Okay, now let's talk about how we can easily terminal velocity, because most of object can easily achieve it and some objects are not able to achieve this terminal velocity. So what is the reason and what are the quantities behind this concept of terminal velocity? So let's suppose if we consider an example of there is no formula to terminal velocity, or there is no specific law or statement related to terminal velocity. You need to learn about the concept of terminal velocity. So if we consider let's suppose a skydiver, if we take example of a skydiver which is going to be jump from a very long distance from the earth, or we can say that from a large distance from the earth. So let's suppose if a skydiver start to move from its original position. So initially we consider the same position like the ball is going to be dropped from the building, right? So first we consider the initial stage. So first of all, let's talk about the initial stage. So number one, so when skydiver starts moving from its original position, let's suppose the skydiver is going to jump from this point. So again, initially we know that skydiver or the speed of the skydiver is equals to 0 because there is no movement in the body of a skydiver. When it starts to jump from its original position, so you already mentioned that speed will increase, right? So initially,
Yes.
velocity or speed of a skydiver okay, so basically the velocity of a skydiver increases, right? And what about the air resistance?
It also increases.
Air resistance also increases, right? So air resistance also increases, but air resistance is the weight of object, right?
So can you repeat? You are lagging.
Basically, I'm saying that if we consider, yes. So if we consider the air resistance, so basically air resistance is not much high to balance the weight of an object at this point, right? Because object is just start to move from its original position. So air resistance take time to balance the weight of an object, right? Because at this
Yeah.
specific point, the weight of an object is acting downward and the friction, that is air resistance, is going to be acting upward direction. So at this particular point, we can say that the weight of an object is greater than air resistance, right? And we also say that the velocity of an object increasing. And what about the
Also greater than 0.
increases? It will also be greater than 0. So air resistance increases, velocity increases, are going to increase at the initial stage, right? And let's consider the after time or after some interval. So this is our initial condition, initial situation, all parties increasing. But after some time, let's suppose at this interval, now object is moving forward, but it is not reached the ground state or the ground floor. So what happens now?
Uh, the air resistance, the air resistance balances out, like the velocity
So we know that now,
or the weight.
yes, as compared to the previous point, now air resistance is going to be increased as compared to the previous position. So air resistance will now is going to be greater as compared to the previous one, and it starts to balance the weight of an object. Let's suppose if you consider two objects, if we drop a stone from, let's suppose 20 meter from the ground, and we drop a paper from the 20 meter height of 20 meter from the ground. So what was your observation? If we drop a
The rock would fall first.
yes. So rock will fall first. And the second thing is that paper starts floating in air, right? Because the weight of paper is not much greater like the weight of that stone. So air resistance balances that paper very quickly after some time, or we can say like after very short time of interval, right?
Yes.
So the second state will be like this. When skydiver speeds up, so air resistance balances. Sorry, to balance the weight of an object. And what about velocity and acceleration at this point when
It
air
starts,
resistance is increased?
Decrease.
Which quantity will decrease, the speed or
the
acceleration?
acceleration will decrease.
Acceleration.
Acceleration will decrease, and what about the speed?
The speed like also
Yes.
slowly decreases as the resistance increases.
So when it starts speed up, because we are now considering the second stage. So at this second stage, when air resistance starts to balance the weight of the body, so we know that now air resistance is going to be increased as compared to the weight of an object, or as the previous stage. So now speed is going to be slow down, right? Because now friction is going to be increased. Friction means the air resistance is going to be increased. So now velocity is going to be decreased at this point if we compare it with the previous one, right?
Yeah,
And the rate of change of velocity is going to be decreased also, because now air resistance is acting in the opposite direction. So
opposite direction.
yes, so acceleration decrease in the sense that change of velocity with respect to time is now a very short, and the speed at which it is going to be increased at the initial stage, that is also going to be slow down at this stage, right?
Yes, sir.
And the next thing is when air resistance is the weight of an object. So what will be next?
The velocity becomes constant. The acceleration is zero,
Yes,
and the resistance is equal to the weight.
Is equal to the weight of the object.
yes. So now we can say that the air resistance weight of an object equals to the air resistance. At this point, the speed of an object will become constant. Forces are balanced on an object. We also know that when body is moving with some speed or a constant speed, so all forces are balanced off on an object. We will also discuss this concept of forces in the next chapter of forces, and acceleration will be equal to zero. So at this particular stage, this constant velocity of an object is known as terminal velocity, right?
Yes, sir.
I think this is a very simple case, really downward motion. And you know about the concept that how action happens. Let's suppose if we consider example of a paratrooper, right? So a paratrooper initially jumps from the surface of that plane or any height, any surface, let's suppose. So when it is starts moving in the downward direction, so first he try to balance his body, right? The skydiver or the paratroopers just spread their arms and spread their legs to quickly balance them,
Yeah,
because they need to cover the height also. So that's why they increase their surface area, because if you increase your surface area, so you will achieve your terminal velocity very quickly. Just like the example of a paper and a stone. Paper has greater surface area, that's why air resistance can easily balance paper in a very short interval of time. So let's suppose if we consider the example of paratrooper. So once paratrooper balances his body in air, and then he opens up his parachute, right? So when he opens his parachute, so what happened next? If you want to continue this scenario with the paratrooper, sorry, yes, with the paratrooper, after this stage, if we consider the paratrooper and he opens up a parachute, so what happened next?
His velocity will suddenly like slow down because he increases surface area by a lot all of a sudden. He will
Yes,
slow down and
yes,
the air resistance will increase.
yes. So at this point, your surface area will increase eventually at in a very immediate reaction. Your parachute opens and your surface area will increase just like 10 times increase, right? Because you know that if you consider your surface area of your body and the surface area of your parachute, so your air resistance will increase like 20 or 10 times as compared to your body, right? So when your surface area accidentally increase very quickly, so at this specific point, your velocity will decrease, right? Your velocity will decrease at this point because parachute opens up at this stage. So your velocity will decrease because air resistance will now overcome the weight of an object, right? So you feel very light at that point because your velocity decreases at that point. So when we are moving in a straight line because constant, we are moving with a constant speed, suddenly what happens, parachute opens, air resistance now increase, or we can say that it overcomes the weight of an object. So that's why our velocity will decrease. So again, there will be a value of acceleration over here, right? Because there is a change in speed of an object, that will be a negative change because there is a decrease in a speed of a body. So that is known as deceleration, right? So A will be, we can say that, retardation or deceleration. And after some time, we need to follow the same procedure from point number one, right? Because again, slowly we will try to balance our body with the help of a parachute also. So after some time, air resistance balances the velocity of weight of an object again, and the acceleration again comes to zero, and again we comes into the state of terminal velocity, right? So if we consider the example of a parachutist or a paratrooper, so in that condition, we approach or we reach to the terminal velocity two times. But if we consider a single object or a single body moving from a height to the ground, so in that particular stage, we can say that terminal velocity can be achieved at any point, but a single time, right?
Yeah.
So any confusion till now?
No, sir, I'm good.
Okay. Okay, just consider a graph for this also. Then we try to discuss some questions also. Okay, so if we consider a speed time graph, right? Speed on y-axis and time on x-axis. So let's suppose if we consider speed on y-axis and time on x-axis, because we are going to only discuss about acceleration and speed, we are not interested to calculate the distance. So let's suppose if we consider speed on y-axis and time on x-axis. So in this particular condition, starting from zero, from the origin, so we need to follow the variation in the graph. So let's suppose when we start our motion, so what will be the shape of the graph?
Uh,
A straight,
there'll be a line going upwards.
yes. So let's suppose at this specific point, we consider that so body will move in a straight line, but not completely straight. There will be a little curve because all forces are not balanced, right? It will take time to balance.
Yeah.
So we can say that it will move like this, slightly curve over there, right?
So isn't that decreasing?
No, it will be like it is going to be constant anytime like this, right?
It's non-uniformly increasing.
Yes, it's non-uniformly in because speed is on y-axis. So we are continuously moving in upward direction.
No, no, I mean like, isn't it supposed to be like this? Something like that.
Um, Actually, we start from maximum one, right? When we start from our 0 point, so we quickly is going to be reached towards the maximum value. So it will
Oh, okay.
like a straight line, but not completely straight, a little curve over there because air resistance at this stage, uh, this is our first stage. Let's see. So air resistance is small, and there is an acceleration, right? So due to that acceleration part, there is a curve in your graph at first stage, right? And after some time, we observe there is a straight line horizontal to the x-axis. So at this stage, or before that, we can say that this slightly curved position, at this slightly curved position,
The air resistance is
yes.
increasing,
So your air
so
resistance
is the acceleration.
is to balance the weight of an object. So air resistance is increasing, and at this particular stage, the air resistance balance weight of an object, right? And at this stage, we
Yeah,
achieve our first terminal. This single body is moving from right to left. So velocity we achieve over there, right? And let's suppose if we consider a paratrooper, right? And suddenly parachutes open. Let's extend this line uh, like this. Okay. The final stage is, let's suppose if we opens up a parachute, and after the opening the parachute, what will happen next? Our speed suddenly decreases, right?
Yes.
So our graph will move down quickly in a short interval of time, right? It will be like this. Is it okay? Because
yes,
there
sir.
is a curve, because time increases. It is not like that in a specific 1 second, speed continuously decrease and becomes constant. So actually this part represents you what? That parachute open, right? So a type of deceleration in our graph. And finally, after some time, again we balances all forces are balanced. Again, air resistance is the object, and you know that when parachutes open, so you move very slowly as compared to the initial stage, right? So that's why we reached a very lower point on the graph. As you can see that when we are at this point, let's suppose this is 40 meter per second or anything, just for numbers. So now we are at this point, right? So now we are moving at slow speed. So again, acceleration balances the weight, sorry, air resistance balances the weight of an object, and this also gives terminal in the same, right? So any confusion?
No, sir.
Because you know the on the graph, because you already solved the question last, and you guys are also. So this is a concept related to free fall motion. If we consider some questions related to it, uh, car varies with time. Okay, question number 3 is for free fall motion. A student drops from rest a table tennis ball in air. What happens to the velocity and to the acceleration of the ball during the first few seconds after release? Okay, I will end after this 4 or 5 minutes, because main concern is
Okay.
about the concept. You
What
already
happened?
have the PDF file.
Option D.
Option B.
No, D. Like both of them
Both of them.
increase.
Yes.
Yeah, D.
In initial stage, you know that both are increasing, so that is not a difficult one. This is also considered as a simple stage. This is related to speed time graph, car traveling on a road. Okay, the question, object falls through the air and air resistance on it increases, the object reaches terminal velocity, which quantity decrease until its
The
terminal
speed.
velocity
The speed.
is reached. Speed.
Yeah.
Yeah.
Okay. It is terms in terms of forces and not
B.
moles. So which quantity increases until its
Air
terminal
resistance.
resistance? This is yes. Question number 13. When a heavy coin falls a short distance towards the ground, it does not reach terminal velocity.
D. The
The weight.
weight of the coin is always more
Yeah,
than
it
the air
didn't get
resistance.
time to balance even because the distance was so short.
Yes, because surface area is also very short and it is also a high dense if we consider it with the water surface also. Question number 15. Which part of the skydiver, part of the graph shows
C.
skydiver falling with terminal velocity?
No, never mind. Never mind. D.
D. Because parachutes open at this stage and sees the,
Yeah, I thought it was asking when the parachute opened.
so D part gives you the concept of that terminal velocity. This is also a very simple concept, not a difficult one. From next class, we also try to solve a tail question. Okay, this is a numerical one. The graph shows how the height of an object above the ground changes with time. What is the terminal velocity? So you need to find the terminal velocity from the graph, but this time we are having a distance time graph. This is height above the ground and this is time.
I think it's C.
A.
C. 1.6 meters per second.
Okay. And how it is 1.6?
4 divided by 2.5. Speed is equal to distance over time.
Okay. Because we know that if we want to calculate the speed is equals to distance over time, and we need to calculate the distance. So this time we need to choose a distance, but uh, that part of distance when body is moving with constant speed. So you observe that there is a curved path. So at this point, speed is not constant. So let's suppose after this point, you may consider any point on the graph and divide it by time. So you will get the right value, right? This is for car also.
Sir, do we rejoin?
No.
All
Uh,
right.
this is only because I want to complete this same topic in the same week. So that is this for speed time section.